Hey guys, let's do this. Get your homeworks out. It's time. First question. I'm going to underline this and say charge is Q. Q over T equals I. That's how to find current. And since time is 1 second, Q equals I. So I'm pretty much trying to find the current. It's the same as the charge flow in 1 second. Draw my picture. You can see all the charge goes to the first one. That's green line. But then it splits up. So some goes down through B. The remaining bit hits the next part. And then it's not going to go through C. It's going to split up again. And then the remaining bit will now go through the 400. But now pink and orange will combine again to make that blue line from before, which will combine with the whatever that color it is to make the green line again. So A's will get all the flow. Look at the next one. It's not series. It's not parallel. It's a combination of both. You're going to start off by drawing a picture. Watch how I draw 100, and then it's either 120 or 150. Now, since those two are in parallel, they should share the same volts. So I'm going to try to find their total resistance. Now, I forget the actual number when I did this, so I just kind of use logic. But the V1 for the 100 drop is to be more than the V2 for the 100 drop, because when you do the resistance for the V2, it ends up being less than 100. And that's why I'm going to use the whole equation, 1 over R1 plus 1 over R2 plus dot, dot, dot. So if you do 1 over 120 plus 1 over 150, and then 1 over that, you get like, I think 66 or 70 or something like that. But it's less than 100. So if I draw my picture, I get 1 over 100, then like, let's say, round it to 70. There's going to be more voltage used for the 100 than there is for the 70, because there's more resistance there in series. So the 100s have the most, and then the 120 and 50 are going to have the same because they're in parallel. Now for the currents, it's really easy. We don't need numbers. All goes through the 100, and it splits up. It doesn't split up equally because 120 is less resistance, so 120 will have more than 150. Is it possible to replace the 120 and have the voltage rating different? Yeah. Pretty much the way to do that is to have, when I combine them, instead of 70, to get more than 100. So if I have more than 100 then, there's be more voltage for the bigger resistance, less for the 100. To do that in parallel, I need to have something that's really big. Something way bigger than 150. So in conclusion, if I replace the 120 with something really big, like in the tens of thousands, I can get a total resistance of like maybe 150 or 130 or something like that. Is it possible to change their current flows? Yeah, totally. I can't change that the 100's got it all, but I can change that the 150 has the least. Like for example, if I place it with 200, the 200 is going to have less than the 150. Finally, look at this thing. This looks kind of brutal, but let's draw a picture of it and make it make sense. From 9 to 0, 200 and 300, those are my first branches, and it comes back together and then goes to either 400 or 500. And then back together. You can see that 200 and 300 have the same voltage, and 400 and 500 have the same voltage. Now what I'm going to do is I'm going to find the total resistance of each of those pairs. The 200 and 300, it's 120 by the whole 1 over equation. And 400 and 500 get 222.2. Those two things are in series now, so I can combine them again and get, what, 342.2? Yeah, that's right. And so I could say that the total resistance is equal to 342.2 ohms. Now I want to calculate the voltage across each one. I'm going to kind of make a new table based on my middle picture. The first thing I'm going to do is I'm going to find the total current using the 342. And I find it to be 0.026, just using 9 volts and 342. I'm making a quick table here, just show it. 9 volts, 120, 222.2, 342, 0.026, and they have the same, so 0.026, 0.026. Now I'm going to find the voltages using math. V equals IR, and I find the voltage for the 120 is 3.12 and 5.84. Look at my other picture on the side. You can see how, I'm about to draw it in, I believe, yeah. Those two sets are equal, so the 120 voltage is the same as 200 and 300. So the 200 300 have 3.12. The 400 500 have 5.84. And I'm running that down below, but you can't see it quite yet because I'm an idiot. There I am. Now, letter C, calculate the current through each resistor. That 0.026 is not correct because that's the total. I'm going to make one more big table where I'm going to put in the first picture. 200, 300, 400, 500. And then I know the voltages though, so I can just do V equals IR and find them. No need to do anything else. So I do that and I get all these numbers. V equals IR since I know the voltages from the previous question and everything else. So there we are. Now letter D, I now remove the 500. Okay, what does that picture look like? Well, the first little bit's not going to change. So I'm still going to have the 200, and 300, which is equal to 120, but then I just go through the 400. So what's the total resistance here going to be? It's going to be 520. But before, it was 342, so the total resistance went up. Yeah, it went up. So that means the total currents go down. So then the 200, 300s have less flow because they have less to split up between them. So those two numbers go down. Because they're splitting less of a total. But now, instead of it splitting again for the 400, 500, the 400 have more current than before. It's going to have all of the reduced current instead of like half of the larger current. And that is Howey physics.